Hello, can you hear me? Sorry, actually, the WebEx app was taking time for updating. So that is why we are starting little bit late, 5 minutes late. So shall we start the class, sir? Shall we start the class? Okay. So I will share the screen with you people. So actually, I think that updation is taking some time. So that is why we are. I am facing the problem. So please wait. So in the last class, we have seen the yeah, we have seen that the deceleration of the vehicle with respect to the aerodynamic drag. तो हमने वो देखा. Then we derived the expression. After that, we discussed the braking efficiency, and we have seen that the braking efficiency is almost similar to the coefficient of friction. Then I said that there are certain situations where braking efficiency is more than 1. After that, we derived the expression for the braking efficiency, eta is equals to v square by 2gs. And sir, IITA and IITB same.
Sir, eta, sir, R, eta and eta will same.
Yeah, eta and beta, they are same, sir. Saurabh, that is what we have derived from here. Okay. So we have seen that the braking efficiency is proportional to v square, and it is inversely proportional to the distance. That means if the braking efficiency is less, the distance is more. The distance is less, braking efficiency will be more. Okay. So now we discuss the weight transfer phenomena as well. Now today we are going to discuss the forces acting on vehicle during braking when moving downhill. Okay. So this is the very, you can say, a common example or the classic analysis for calculating the forces when the vehicle is moving downhill. So today we will discuss that. Okay. So please note that most of the numericals, they are based on whatever equations we will be deriving right now. So please pay attention. So the first case is the forces forces acting on vehicle during braking when moving downhill. When moving downhill. So I will draw the figure. Let us say that this is the downhill slope. This angle is theta with the horizontal. Here we have got the vehicle which is moving downhill. I am drawing vehicle as a square box. Okay, so it is moving downhill. This is the CG of the vehicle, which is located at a distance of h. If we draw this, then we can say that this is the reaction at front wheel. This is the reaction at rear wheel. Then weight of the vehicle will act in the downward direction, so that is the W. So this angle will become equal to theta. There will be two component. So this is the component which we can say that W sine of theta. Yes or no, sir? This you have studied in banking of roads. And this component which is perpendicular, so this is nothing but W cos of theta. This is W cos of theta. Now there will be a frictional force which will be acting. Let us say that this is x-axis, this is y-axis. There will be resultant force which will be acting in this particular direction, that is W by G into F. So this is the front of the vehicle. This is going to be the front of the vehicle. Let us say that the distance between this distance between this and this, you can give that distance as B. That is nothing but the wheelbase of the vehicle. So I will write down whatever we are going to discuss. So W is equal to gross vehicle weight, then RF and RR, that is equals to front and rear. Front and rear normal reaction, front and rear wheel normal reaction. Please understand that this normal reaction will be useful when we design the suspension system for the vehicle. So B is nothing but the wheelbase. Then L is the distance of CG. So this distance L is distance of CG from rear wheel. Basically this is the perpendicular distance. Okay, then FR, which I have not shown, we will discuss this. FR is equals to braking force at rear wheels okay, and W by G into F is going to be the inertia force. Inertia force. Basically, this is the total force which is acting on the vehicle, because the vehicle is moving in the front direction. So this resultant force has to be there in the front direction. So F is acceleration due to or deceleration due to braking, deceleration due to braking. Okay, h is height of CG from the surface, that is road surface. Okay, so these are the things which these are the forces which will act on the vehicle when the vehicle will move down the hill. Sir, I would just like to tell you about this weight. Here it is, weight is written as the gross vehicle weight. So what is the definition of the gross vehicle weight? See, if you consider the weight of vehicle, so we have got three terms which are used here: gross vehicle weight, then unladen weight, then laden weight. So what is the difference between these three weights of the vehicle? Sir, can you throw some light on this? Sir, please answer in the chat box, or you can unmute the mic and can speak about this. See, I have said that weight of vehicle can be defined in three ways: the gross vehicle weight, which we have used here, then unladen weight, and then the laden weight. So what, in your opinion, what is gross vehicle weight, what is unladen weight, and what is laden weight? There is another term which is used in industry, that is curb weight of the vehicle. So sir, what is that? Sir, what is the curb weight? सर बताइए क्या क्या डिफरेंस है? सो गए क्या सर सब? आर यू एबल टू हियर मी? सर जब तक कि आप आंसर नहीं देते तब तक के सर ये ऐसे ही चलेगा. आई विल नॉट स्पीक. Weight including the passenger, gross weight. So gross means total, including people. Okay. Then gross weight is the weight of vehicle with passenger. Okay. Gross weight includes the passenger. Okay. Weight with passenger, gross weight. Okay. Sir, any other answer, sir? आप सर सिर्फ पैसेंजर के बारे में ही सोचते हो, लगेज के बारे में कौन सोचेगा सर? So gross vehicle weight is including passenger and the luggage. Then laden weight is almost the same. The almost means it is going to be same, including the passengers and you can say luggage, then because the luggage carrying capacity has to be taken into consideration, then the gross weight and laden weight, they are the same. Unladen weight is you remove the co-passengers and the luggage, so that becomes your unladen weight. And curb weight, it is meaning just weight of the vehicle without occupant or baggage. Okay, so these are basically the only vehicle weight. That means there is no person sitting, no luggage is there, so whatever vehicle is there, so that is the curb weight. Why I ask you these questions? Because whenever you read any you can say specification regarding the testing of the emission of the vehicle, then all these weights, they are to be mentioned in that particular document, and based on that you have to test the vehicle. Okay, so सर ये ख्याल में रखो. तो थोड़ी सी नींद कम करो, सवेरे का समय है, आई कैन अंडरस्टैंड, बट थोड़ी सी नींद से जागो. सर सौरभ कुमार सर, प्लीज थोड़ा सा नींद से जागिएगा सर. मैं बोल रहा हूँ कि ग्रॉस व्हीकल वेट और लैडन वेट सेम है. अनलैडन वेट में आप ड्राइवर बैठा दीजिए और बाकी के सब रिमूव कर दीजिए, दैट बिकम्स योर अनलैडन वेट. अनलैडन में कुछ भी नहीं होगा. एंड कर्व वेट में सिर्फ ड्राइवर भी नहीं, कुछ भी नहीं, लगे बैगेज भी नहीं, जो वेट रहेगा दैट इज बेसिकली कर्व वेट. ओके, तो सर ये अनलैडन वेट कुछ जगह में ये दे से दैट कि लगेज नहीं रहेगा, कुछ भी नहीं रहेगा, ओनली ड्राइवर विल बी ड्राइविंग द व्हीकल, ओनली वेट ऑफ द ड्राइवर हैज टू बी एडेड हियर. लैडन वेट में और ग्रॉस व्हीकल वेट में कुछ भी फर्क नहीं है, बिकॉज यू हैव टू कंसिडर बैगेज एंड पैसेंजर, को पैसेंजर, ऑल वेट्स ऑफ ऑल. एंड कर्व वेट इज ओनली ब्लैंक व्हीकल, no driver, nothing else, that is curve weight. Okay, so this is specifically useful when you specify, you design the new vehicle and give it for the testing for the emission, then you have to declare all this data. Okay, does that answer your question? Now coming back to the forces acting on the vehicle during braking when moving downhill, there can be three possible cases for braking. So I will write down the three possible cases for braking. So सबसे पहली केस ये है, brakes applied to rear wheels only. Brakes applied to rear wheels only. Then second is brakes applied to front wheels only. Then the third case is brakes applied to all four wheels. So we have to analyze these cases. So shall we move ahead? सर चलो फिर ये एनालाइज करने का सर. ओके, तो सर नाउ ब्रेक्स अप्लाइड टू रियर व्हील ओनली. तो सर मैं जस्ट फिगर निकालता हूं. ब्रेक्स अप्लाइड टू रियर व्हील्स ओनली. तो सर ये आपका स्लोप है, इसके ऊपर ये थीटा एंगल. तो ये सी जी, यहाँ से ये डब्ल्यू नीचे, ये आपको डब्ल्यू साइन ऑफ थीटा, देन यहाँ आपको डब्ल्यू बाई जी इंटू एफ, ये आपका फोर्स एक्टिंग आर आर रियर व्हील, ये हो गया आर एफ. ठीक है. नाउ सिंस द फोर्स इज एक्टिंग ऑन द रियर व्हील, you can have the friction force here, so that is denoted by friction force is Fr, that is the rear force, then this is mu into Rr. Okay, So that is basically the friction force which will act. Now again the distance is, this distance is L. व्हील बेस का आपको डिस्टेंस मालूम है, ये जो यहाँ जो डिस्टेंस है ये व्हील बेस है, और सर ये हाइट है h. तो चलो सर अभी फोर्स बैलेंस इक्वेशन लिखते हैं. ब्रेकिंग फोर्स विल एक्ट ऑन braking force will act on only rear wheels. When I am saying wheels, it is acting on both the wheels. So we will consider the combined thing. So Fr is equals to mu into Rr. So this is the limiting value of the braking force. Okay. Then under equilibrium, we can write for y direction, what are the forces which are acting? Rf plus Rr, that is equals to W cos of theta. Let us say that this is your equation number 1. Okay, do you agree with this? Now for x direction, please tell me. So for x direction, the forces acting, they are Fr is equals to mu Rr. Against this all other forces are acting, so W sine of theta plus W by G into F. Let us say that this is your equation number 2. Now here we have to get the expression for Rf and Rr. Okay, so our aim is to find out Rf and Rr. What are the reactions at the front and the rear wheel? So sir, taking moment of forces about front wheel contact point. So taking moment of forces about front wheel contact point. That means at this particular point, front wheel contact point is this. So we can write down W by G into F, whole thing multiplied by H, plus W sine of theta multiplied by H, plus Rr into B, that has to be equal to W cos of theta in bracket B minus L. Let us say that this is our equation number 3. All of you agree with equation number 3? Please check once again. W by G into F, that is multiplied by H, that is the distance, perpendicular distance. Then W sine theta into H. So this is the W sine theta into H. Okay, so that distance we have seen. Then Rr into B, this Rr into this total distance is the wheel base, so Rr into B. So all these moments, they are in the same direction, that is the anti-clockwise direction. That has to be balanced by W cos theta, because W cos theta is acting here. You can say that this is going to be the action of W cos of theta. This angle is going to be theta. So W cos theta in bracket B minus L, this is your equation number 3. Okay, so now putting the value of Rr, putting the value of Rr, putting the value of Rr is equal to, ये Rr यहाँ से लेना है सर अपने को, Rr नहीं, ये सेकंड इक्वेशन से लेना है सर. So RR, I will write down the expression for that. So putting the value of RR is equal to W sin of theta by mu, ये सेकंड इक्वेशन से लेना है सर, ये RR यहाँ से प्लस W by G in bracket F by mu from equation 2 in equation 3, यानी यहाँ से ये वैल्यू यहाँ सब्स्टिट्यूट करना है सर. अगर आपने ये वैल्यू सब्स्टिट्यूट की तो आई विल राइट डाउन द इक्वेशन कि कौन सा मिलेगा हमको इक्वेशन. सर I think all of you are with me or today you are sleeping. I am getting that feeling. सर आज बहुत नींद आ रही है क्या आपको? प्लस W sin of theta into H plus W sin of theta B by mu प्लस, सर ये नहीं तो आप एनालिसिस कर लेंगे क्या सर? अपन फिर डायरेक्ट ये एनालिसिस स्किप करके एंटीलॉक ब्रेकिंग सिस्टम का डिस्कशन करें क्या सर? दिस इज इक्वल्स टू W cos of theta B minus L. ओके, सो सर प्लीज बताइएगा. सो रीअरेंजिंग above equation we get. सर मैं अभी नेक्स्ट पेज पे शिफ्ट हो जाऊं क्या सर? चलो ठीक है. इसके बाद वाले मैं सर डेरिवेशन दोनों केस के स्किप कर दूंगा, मैं फाइनल आंसर दे दूंगा. नाउ दैट विल बिकम योर हेडेक. ओके, सो वी गेट F by G that is equal to mu into B minus L cos of theta B plus mu H minus sin of theta. So this you get the expression for the deceleration, and then the rear force में सर आपको ये मिलेगा B minus L cos theta divided by B plus mu H into W, and RF is equals to ये रहेगा W cos of theta minus of B minus L cos of theta divided by B plus mu H whole thing multiplied by W. अगर इसको सिंप्लीफाई करोगे तो सर आपको ये मिलेगा L plus mu H divided by B plus mu H cos of theta into W. Okay, now these are the front wheel reaction and the rear wheel reaction. So these equations they are useful in calculating how much amount of the load which has to be there, because based on this your frictional force is dependent, because the braking force is equals to this particular reaction multiplied by omega. Since there is a weight transfer phenomena, the RR and RF will not be equal to same. Okay, now the next case I will just give you the final expression, because looking at your interest I don't feel that I should derive these equations for you. So I will write down the final equations. So brakes applied to front wheels only. So you are requested to derive the equation in the similar way. Now here braking force will be only applied to the front wheels. So braking force is applied to फ्रंट व्हील्स ओनली। तो सर ये जो फ्रंट व्हील का जो एफ रहेगा ये म्यू इंटू आर एफ रहेगा। ये है लिमिटिंग वैल्यू। ठीक है, तो इसके सर मैं 3 एक्सप्रेशन लिख के देता हूं, आप डायग्राम एंड अदर थिंग यू कैन ड्रॉ ऑन। तो एफ बाय जी इज इक्वल टू म्यू एल कॉस ऑफ थीटा डिवाइडेड बाय बी माइनस म्यू एच माइनस ऑफ साइन थीटा। ठीक है, ये वैल्यू आएगी। आर आर की वैल्यू या आर एफ की वैल्यू मैं आपको लिख के देता हूं। So RF comes out to be, sorry, RR comes out to be B minus L minus mu H divided by B minus mu H whole thing multiplied by cos theta into W, and RF comes out to be L cos of theta divided by B minus mu H whole thing multiplied by W. So this is for the second case, but you are requested to derive that if you happen to get the time, otherwise I will ask you to derive it in exam. Brakes applied to all 4 wheels. तो सर अगर चारों व्हील को अगर ब्रेक्स अप्लाई किए तो आपको मिलेगा ये ब्रेकिंग फोर्स, ये एफ एफ इज इक्वल टू म्यू आर एफ एंड एफ आर इज इक्वल टू म्यू आर आर, and then finally you get F by G is equals to mu cos of theta minus sin of theta. Then RF comes out to be mu H plus L bracket complete cos of theta divided by B minus W, sorry B into W, and RR जो मिलेगा आपको वो मिलेगा B minus L minus mu H divided by B cos of theta into W. तो सर अभी ये इक्वेशन में आप थीटा इज इक्वल टू 0 अगर रख दिए, इफ यू अप्लाई इन ऑल इक्वेशंस, if theta becomes equal to 0, then it is valid for plain road. Please note that here all these equations are also applicable when vehicle moves up gradient. Then what will happen? Only sine of sin theta alters, changing the value of F by G. The expressions for RR and RF remains unaffected. Okay, so this is basically the total story as to how to find out the reactions at the wheel when you apply the brakes at the front, when you apply the brakes at the rear, when you apply the brakes at all the 4 wheels. So based on this force analysis, you can derive the reaction. There you can verify what is exactly the weight transfer phenomena, because when you apply the brakes then some amount of weight is getting transferred from rear to front. And this is the situation. We derived the expression for the downhill. Same can be done with the uphill. If you happen to get the time, please do it for the uphill. You can say when the vehicle is moving uphill, the W by G into F, that will change the direction. Rest all will remain the same. Okay, that is why he's saying that the sin theta का साइन जो है वो चेंज हो जाएगा. तो सर ये चीजें आपको समझ में आई क्या? तो सर ये आपको टोटल मैथमेटिकल एनालिसिस करना है. Please understand that there is complete book which is written on the brake system, then stopping distance and other vehicle dynamics parameters are discussed. So brake is not that small topic what we understand. Okay, so this is basically the idea. तो सर अभी इसके ऊपर एक प्रॉब्लम सॉल्व करना क्या? बहुत लंबा चौड़ा प्रॉब्लम है. So shall we go ahead sir with your permission? Which is better out of three cases? Sir, there is nothing like which is better out of three cases. You need to apply the brake to all the four wheels. Otherwise, there will be additional kinetic energy which may create the problem. Okay, so whenever you apply the brakes are applied to all the four wheels. Okay, so this particular case, the brakes applied to all the four wheels, that is you can say that it is the better case. There will not be any accident, but we have to analyze this and then make sure that, because in both the cases, if you stop the front wheel, the rear wheel keeps on moving and can transfer the weight. If you only apply the brakes to rear, then front wheel can drag the vehicle. So you have to apply the brakes to the limit that it should not get locked up, and that is the best thing is to apply the brake to all the four wheels. So does that answer your question, Saurabh? It is basically, if you think from the kinetic point of view, you should get the answer. Okay. Now sir आगे बढ़े क्या, प्रॉब्लम सॉल्व करें? चलो सर, with your permission we'll solve the problem. नो ये सर काफी लंबा चौड़ा प्रॉब्लम है, तो सर मैं नए शीट पे अगर प्रॉब्लम सॉल्व करूंगा तो कोई दिक्कत तो नहीं है शायद. आई विल चेंज इट टू द न्यू शीट, न्यू ब्लैंक बोर्ड. तो लेट अस ट्राई टू सॉल्व द प्रॉब्लम. चलो, आप तो लिखते नहीं हैं, आप तो, क्योंकि मैं आपको नोट्स भेजता हूं तो आप तो कष्ट करेंगे नहीं, मुझे मालूम है. सो प्रॉब्लम इज derive an expression for the stopping distance in meters of a truck equipped with all wheel brakes in terms of coefficient of friction, and speed in kilometer per hour. Okay, calculate the value of coefficient of friction mu if the vehicle is stopped, in 27.45 meters from 64 kilometer per hour if the coefficient of friction is reduced to 0.3 by rain, what will be stopping distance? Predict. पर ये पार्ट नंबर 1 है, ये पार्ट नंबर 2 है, ये पार्ट नंबर 3 है प्रॉब्लम का. Predict stopping distance in either case. In either case, comma, if instead of truck, comma, a car weighing a quarter of truck is used in the experiment. तो चलो सर, अभी इसको आप कैसे करेंगे सॉल्व, थोड़ा सा सोचिए पार्ट 1 का. तो पार्ट 1 का सर ये देखिए कि ये प्लेन सरफेस है क्योंकि इसने ग्रेडियंट नहीं दिया हुआ है. तो ये सर ट्रक के व्हील्स है, ये मान लो आपका ट्रक का बॉडी है, ठीक है. यहाँ ये CG है, ये वेट W, ये डिस्टेंस आपका h है, और ये जो है ये आपका W/G × F है. तो ये हो गया आपका RF, ये हो गया RR, और सर यहाँ जो रहेगा ये फ्रिक्शन फोर्स अगेंस्ट दिस, यहाँ लगेगा सर फ्रिक्शन फोर्स. तो देखते हैं कि फ्रिक्शन फोर्स सर यहाँ लगेगा. So FF is equals to mu into RF and FR is equals to mu into RR. तो सर अभी कैलकुलेट करिएगा. ये हो गया आपका इधर x एक्सिस, इधर ये y एक्सिस. तो सर अभी कैसे कैलकुलेट करेंगे सर इसको? In case of all four-wheel brakes are applied, forces will act to give dynamic equilibrium. So under dynamic equilibrium, summation of forces along y-axis has to be 0 and summation of forces about x horizontal is 0. So W is equals to RR plus RF. So this is one thing, and second is W/G into F is equals to mu RR plus RF. Okay, so you know that W/G into F is equals to mu into W from the first equation. So from here you get F is equals to mu, यानी जो डिसलरेशन है वो म्यू इंटू जी मिलेगा आपको, ठीक है. ये म्यू इंटू जी मिलेगा. ऑल ऑफ यू एग्री विद दिस? और आई कैन ये इसको थोड़ा सा मिटा देते. सो F कम्स आउट टू बी म्यू इंटू जी. So this is the expression for the answer for the first case in terms of coefficient of friction and speed in kilometers. So F comes out to be mu into G. So that is the answer. Now stopping distance. So sir, stopping distance कैसा है sir? Velocity V is given as 64, no? Or velocity V, you can say that this is in kilometer per hour. So if you convert it V in meter per second, so it will be V in km, kilometer per hour, divided by 3.6. So stopping distance is V square divided by, or you can say that this equation you can apply under constant deceleration. V square is equals to U square plus 2as. Here final velocity is 0. Initial velocity is V by 3.6 and minus F, or you can say A is equals to minus of F. So if you put this value, so 0 is equal to V square by 3.6 का square into 2 into minus of F into S. तो ये सर ये प्लस होगा सर, sorry. So from here S comes out to be V square divided by, ये F का जो वैल्यू है ये म्यू जी है, तो V स्क्वायर अपॉन 254.28 म्यू मिलेगा सर आपको. जस्ट चेक करिएगा ये इक्वेशन से. So sir, V square comes out to be ये V square plus V square is equals to U square plus 2as, तो ये इक्वेशन से ये मिलेगा. So now the second case is if mu is equals to 0.3 and V is equals to 64 kilometer per hour, then S comes out to be 64 का square divided by 254.28 into 0.3. So this comes out to be 53.7 meters. Okay. And answer to the last question is, since expression derived is independent of the vehicle mass for the same mu and v, stopping distance will not change if truck is replaced by car. So stopping distance is independent of mass of vehicle, hence it will be same in case of car. So this is the answer to the last question. So if you have any doubt, please do ask. If you do not have any doubts, then we will stop here. सर किसी को कुछ डाउट है क्या सर? है तो पूछिएगा. ओके चलो क्लियर. धन्यवाद सर. I will stop sharing the screen. Okay. Now over from my side, you can leave the meeting.